Hi everyone, today in Integrated Math 2 we're going to go over Chapter 4, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, so we have a parent function of exponential growth functions. And as you can see here, it's f of x is equal to b to the power of x. And b must be greater than 1. As you can see, it's continuous, 101, and increasing. The domain is all real numbers, and the range is all positive real numbers, as you can see. And the intercept in this case is 0, 1. And the way this graph can be moved, we can have horizontal translations, h units to the right. If h is positive, absolute value of h units to the left, if h is negative. And you can see that's where this comes in handy for our formula. And if we have k, this k represents the units up if k is positive, and its absolute value of k is the units down if it's negative. The a, if we have an a here with our exponential function, that means it's going to determine the orientation and the shape. If a is less than 0, the graph is reflected on the x-axis. If the absolute value of a is greater than 1, then the graph is stretched vertically. Then if 0 is less than the absolute value of a and a is less than 1, the graph is compressed vertically. And as you can see here, this is a parent function for exponential decay. Remember, the other one was increasing. This one's going in the opposite direction. 0 is less than b, and b is less than 1. Alright, so let's try example 1. We want to graph f of x, which is equal to negative 2 times 3 to the power of x plus 1. We want to state the domain and the range. Well, if I'm looking at this one, I would not know how to graph it. But if we do not know how to graph it, we can... They don't want me doing it that way, do they? Alright, so for this one, since we're not exactly sure how it's going to look, but we want to get the best idea on how it will look, we're going to make a little t-chart. So we're going to find x values, choose x values, and then we're going to find our y values with that. So my first x value that I'm going to choose, I'm going to say, let's just go ahead and start with 1. So I'm going to plug in, every single time we see an x, I'm going to plug it in for 1. So I have negative 2 times 3 to the power of 1 plus 1. Well, use PEMDAS, your order of operations. 3 to the power of 1 is 3. Times that by negative 2 plus 1. Then you multiply. That gives you negative 6 plus 1, which will give you negative 5. So 1 and negative 5. Then I'm going to go ahead and, let's say, choose 0. Negative 2 times 3 to the power of 0 plus 1. Anything to the 0 power is always 1. Then we have negative 2 times 1, which is negative 2 plus 1. And that's going to give us negative 1. So 0 and negative 1. Now I'm getting a better idea of what I'm going to be graphing. So now let's go ahead and choose negative 1 for x. So now we have negative 2 times 3 to the negative first power plus 1. Remember, if you have it to a negative power, you're going to go ahead and make it a fraction. So negative 2 times 1/3 plus 1. And if we don't remember that negative power rule, we'll be going over that, and that might be something that you need to refresh your memory on. on exponential rules. Negative 2 times 1/3 is negative 2/3 plus 1. Well, I can't just add these together, but I know 1 can also be made 3/3. So negative 2/3 plus 3/3, which makes that 1/3. And let's just say, let's try one more. I want to try another negative. Negative 2. So I have negative 2 times 3 to the negative 2 power plus 1. Then I have negative 2 times 1/9 plus 1. Then negative 2 times 1/9 is negative 2/9 plus 1. We have to get our common denominator again. In this case, it'll be 9. So negative 2/9 plus 9/9. Negative 2 plus 9 is 7. So we have 7/9. So we have all these different points. Now we're going to go ahead and plot them. And that'll make it easier for us to see the domain and our range. So here we have it graphed. I would have connected all the points, and this is what you would have seen. Then we see that domain is all real numbers. Remember, the domain represents our x values. Our x values do not have any limits. So keep on going. And our range is all real numbers less than 1. And I say that because you're going to see it's never going to go past this 1. So it's going to be less than 1.